you start the you start the 6.5, okay? Protocolos de transferência de dados usados por IoT, okay? As I told, in the last question, we discussed a lot of different protocols, but it's only an introduction because it's very difficult to discuss about the LTE, NB-IoT, or the LoRa and others without have the network background. The last topic is only about one overview, okay? It's what's easiest, okay? But it's not to go deep. Today, you study 3 protocols that we use to implement IoT, okay? It's in a different layer, okay? It's a different perspective to see the IoT. The protocols that we studied last class is more applied, for example, to people that develop protocols or people that work with the telecommunication, okay? Today, we study protocols in the application layer that is related involved with the computer guys, okay? To understand what we'll talk today, the first thing you need to understand or to revise, because you already studied about what is a protocol. One example of the protocol is like a translator, no? For example, things. I speak Portuguese, you speak Spanish. We use the protocol English to be possible that I and you understand the meaning of the message, okay? For example, we use a protocol to enable that the transmitter and the receiver can understand the message. Okay, it's the example of the English and Portuguese. English, it's our example, no? In Spanish and English, Spanish and Portuguese, and use English protocol to translate the Spanish to English and English to Portuguese. Okay. The protocol defines a set of things. First, the rules, okay? For example, the rules is in the English, no? If you can say, for example, the rules, okay. You only can use the protocol English if you speak Portuguese or Spanish. You cannot translate, for example, Russian, okay? The syntax, okay? For example, one word that I know in Spanish. Listo in Spanish is pronto in Portuguese, that is read in English, okay? It's an example of syntax. And synchronization. In our case is, if I talk, you listen. If you talk, I'm listening, okay? It's rules of synchronization. And possible errors or in recovery methods. For example, when you didn't understand one message that I say, you said, Professor, I didn't understand, can you repeat? Is on a process or it's like a rule to handle errors. Did you understand? I start to record.
Yes.
Okay. So in a network, you already see it in the video, the first video that I show about network. But again, I talk again. In the network, you have the usados model. What is Osai model? Osai model is a conceptual framework that split the communication task in different subtasks. Okay, the idea is you split the communication in set layers or in set stacks. Okay, the bits, the physical, the data links, the network, the segments or transport, the session, presentation, and application. Okay, each stack or each layer here has a specific function and provides service to the other layer. For example, network layer provides service to the transportation. Okay, to the transportation. Data link layer provides service to the network layer. Did you understand? So you have seven layers. The main idea to develop this model, before this model exists, the network communication, you don't have layers. For example, if you are the developer of the one network application, you need to define the application. You need to define the NIC. You need to the interface, the network interface, the NIC that you install in your computer. You need to define the cable. You need to define any item in the network. The problem, if you buy a network cable from one provider, you need to buy the rest of the system, the computers, the NIC, the switches, the routers, the security from the same provider. You cannot, for example, like today, you buy a computer from Asus, a NIC from Intel, a switch from Cisco, and a smartphone from Samsung. It's a completely separate type of application. Okay, you can select the provider that is better for you. Okay, it's only be possible because each provider implement part of this stack. Again, this stack has 7 layers. The first layer is the physical one. The physical is responsible to transform the. I invert. The first layer is the application. Okay. In a practical perspective, okay, this 3-layer is implement only one layer. For example, in the TCP/IP stack, it represents one layer, the application layer. The application layer is the layer that you develop the application. For example, the WhatsApp. For example, the Google search. For example, the Outlook. This application is developed here in the application layer. When you type one message and press the button to send this message, you need to transport this data. Use the transport protocol. Remember the idea, because when you send one data to another place, okay, A wants to talk with B, for example, my computer wants to send a data to your computer in Mexico. Your data, you transport for many paths, okay? You can use path 1, path 2, path 3, path 5, for example, it's dependent. And the transport layer ensure that this data has, my computer and your computer has a logical chain. What is a logical chain? It's a thing that does not exist in the physical world, but it's logical. You create like a tunnel between my computer and your computer. It's what the transport layer does. The next layer is the network. The network, remember the picture that you have a data that can go to one route or to others. The network layer defines 2 things. First, the address scan like IP, and the second, define the route. It's the layer that defines for example, one data, when you receive a data, you define if this data is yours or not. If it's not yours, you define the next step or the next path. The data link, it is responsible for the physical address. I don't talk about it now because it's you'll study it next year. But it's responsible, for example, to transform, to define, remember the wireless. Think about the dark room, okay? We are in the dark room, nobody see the others, okay? In the dark room, remember the history. If one guy talk, the other need to listen. The data link define this protocol, how to access the medium, okay? Independent this medium is wireless, Wi-Fi, wireless, wired, it don't matter. This data link define how you access the medium. And finally, you have the physical. The physical is responsible to transform the data in a physical representation. What it means? If you use wireless, the physical data, the physical layer is responsible for transform the data in the electromagnetic pulse or RF pulse. If you use metallic cabling, it's transform the data to electric pulse, zeros and one, okay, volt or not volt. If you use fiber, okay, it transforms the data in pulse of light, okay. Again, you will study it last year, okay. It's only an overview. So there is this video here that explains the OS model in detail. Please pay attention to watch this video. It's a very nice video, okay?
Welcome to Cert Bros. In this video, we're going to be taking a look at the OSI model. So, what is the OSI model? The model is a theoretical stack of 7 layers that can be used as a reference to help understand how networks operate. The model was introduced to standardize networks in a way that allowed multi-vendor systems. Prior to this, you would only be able to have a one-vendor network because the devices from one vendor couldn't communicate with others. It's worth noting at this point that we don't actually use the OSI model. We use something called the TCP/IP model. The concepts are exactly the same. The layers are slightly different. So if we don't use the OSI model, why would we bother learning it? Well, that's because it's still referenced a lot when troubleshooting or describing network operations. Let's take a look at the layers starting from the bottom up. Layer 1 is the physical layer. The physical layer is the lowest layer of the OSI model. Its key responsibility is to carry the data across physical hardware such as Ethernet cables. Layer 2 is the data link layer. At this layer, the physical addresses are added to the data. This is the source and destination MAC addresses. Switches are located at this layer. The network layer handles IP addressing and routing. At this stage of the OSI model, the source and destination IP address are added. Routers operate on this layer. Layer 4, the transport. The transport layer of the OSI model adds the transport protocols such as TCP and UDP. TCP, for example, is used for error handling and sequencing to ensure no data is lost. This layer also adds the source and destination port numbers. Layer 5, session. This layer is responsible for establishing and terminating connections between devices. Layer 6, presentation. This layer formats the data in a way the receiving application can understand it. This layer is also able to encrypt and decrypt data if needed. Layer 7, application. This layer is where the application and user communicates. Application-specific protocols are used here, such as SMTP, if you're sending an email, for example. A really good way to remember these layers is simply, all people seem to need data processing. APSTNDP. So to fully understand how this model works, you need to see a real-world example. Let's say you send an email. The data travels through the OSI model, adding and processing data on each layer. Now this process is called encapsulation. Step 1, the application layer. Outlook creates the data, the email you wrote, the email addresses, etc., etc., and gets ready to send it using SMTP, which is the Simple Mail Transfer Protocol. Step 2, presentation layer. The data is formatted in a way the receiving device will understand. In this example, probably ASCII. This layer could also encrypt the data if needed. Step 3, session layer. A session with a receiving mail server is started. Step 4, transport. This is where it decides to use TCP or UDP. In this case, we'll use TCP to make sure every packet gets delivered. Also, the source and destination port is added to the data. Step 5, network. The IP address of the mail server is added as the destination, and the source IP address is also added to the data. Step 6, data link. The MAC address of the router and the source MAC address of the host is added to the data. Step 7, physical. The data is sent out on the network using Ethernet. So when the data reaches the other side, the receiving device will process the data in the same way but in reverse, starting from the bottom up. Okay, so that's the OSI model, but how can we use this to troubleshoot? You may have heard the term, oh, that's a layer 2 problem, or sounds like a layer 3 issue. When you hear that, that's people referring to this model. Let's say there's a problem with the network. If we go through this model, checking every layer, we can soon diagnose the problem. For example, layer 1, are all the cables plugged in? Is the network card functioning? Could it be a faulty cable? Layer 2, maybe the switch has gone bad. Layer 3, is the router functioning? Do I have the right IP address? And the process goes on and on from there. I hope you've enjoyed this video. If you have, remember to subscribe, comment, and give a thumbs up. Thank you for watching.
Okay, we studied today 2 layers, okay? The application layer and the transport layer. The first one is the transport layer. The transport layer is responsible. Okay, before, any questions about the video? Is it a little more clear what is the OSI model?
Yes.
Okay. The transport layer is responsible for the end-to-end connection and reliability. Again, as I told, is responsible for a logical communications between the application running in different hosts, for example, my computer and your computer, okay? And a very important feature that this layer provides is the reliability. We'll have in the TCP/IP stack 2 protocols in the transport layer. The TCP and UDP. The TCP is the protocol that ensures that you have reliability in the channel. It works like, for example, like we do here in the course. For example, I say, "Olá, como é?" I say, "Hello, how are you doing?" And I need to answer something. I need to ensure that you receive my message. And before you answer, you send acknowledge, like, "Oh, I received your message." It's what happens here. The sender sends the data and receiver send an SK. And what means the SK? The SK means, okay, I received the data. Send another data and you send the SK. There is a very important task in the TCP that is established the session, because to start to talk, you need to establish one session. The name of this phase is the three-way handshake, okay? Three-way handshake. Again, you study this three-way handshake in the network course. But what it means? It is, it's like, for example, I say, for example, "Adrian, are you here?" And you say, "Yes, I'm here." Okay. When you say, "I'm here," and I answer, "Okay, I hear that you are here." Okay. It's like if this one, the originator send, "Hi, I need to talk with B." And B say, "I'm here." And they say, "Okay, I listen, I hear that you are here." Okay, it's a three-way handshake because it happens in three phases. The second part is ensure reliable delivery. Again, because all the messages that you receive, you send an SK. Okay, for example, send data 1, you say SK1. You send data 2, you answer SK2. Provide same order delivery, because when you send the SK, you inform the data that you receive. Okay, I explain a little better. And support flow controls. The problem to use, for example, this approach, you send a message, receive a SK, send a message, receive a SK. You generate a lot of reply message, TSKs. It's completely unproductive. Okay, better options is this approach here, when you have a thing that the name is a window. What is a window? A window is a size of the number of the package that you can receive without any ACK. Okay, number of packets that you can receive without answer with an SK. Okay. Okay, it's the window. In this case here, see this case. You send the data 1, data 2, data 3, data 4, data 5, and the SK say, "Oh, I received the SK 5. Okay, the SK all the time inform the message that you receive. And you say, "Okay, send data 6, 7, 8, 9, 10, and you answer the SK 10. But think this example here, okay? You have the node 1, and you have the node 2, okay? And the node 1 send the message 1, okay? And this guy send the message 1, the message 2, the message 3, the message 4, for example. thinks that the window is equal 4. Okay? Did you understand? Yes or no?
Yes, teacher.
If your window is 4, you need to send an SK, am I correct? And I said that the ACK is ACK 4. Okay? The ACK related to the message 4. Did you understand?
Yes.
We try to think another example. Think that you lost the message tree. The message tree never arrive to the destination. You lost the message 4. Every time that you start the communication, you have a time window. Okay, you start a clock here. Okay, and okay, and you're waiting for a time. Okay, if you didn't receive another message and the time window is 4, you need to do something. Okay, what you do? Your answer will be ACK 3. Why 3? Because it's the last message that you receive. Did you understand?
Wait, teacher, I thought it was just me and I was trying to fix it, but I only see a white screen.
You
Yeah,
didn't
like
see
a white
what?
square. Yeah, just a white square, like it's a phone share.
I thought it was me,
Oh,
but
Yeah,
okay, yeah,
now
I already see
there
it.
we go.
Yes.
oh my gosh! Sorry. Thank you, Esther. Oh my gosh. Okay, I repeat. Okay, I repeat. I'm back a little. Okay. As I told, you have a window 4, okay? It means that you can send 4 messages and don't need to receive any ACK. In this case, if everything is okay, you send a ACK 4. Okay? What it means? It means that you receive all messages, including the message 4. Until here, did you understand? Yes or no? Okay. So, think on this situation. Things that you didn't receive, never receive the message for, okay? Okay, you didn't receive the message for. What happens is, every time that you start the communication, you start a clock and you define a timeout time, okay? If you didn't receive any message until the time 4, because here the red block, wait, okay, the guy sent 1, the guy sent 2, the guy sent 3, I need to receive the 4, and I didn't receive. What you do? You answer the message with a ASK 3. Why ASK 3? Because we receive 1, 2, and 3. You need to wait, you're waiting for the 4. And you inform, oh, I didn't receive the 4, I received the 3. Did you understand until here? Yes or no, guys?
That you send 1, 2, 3, and 4, no? Or
Yeah,
4, no?
for the block, the red note didn't receive.
Okay.
Okay. We think a little different. Okay. No, before, sorry. Okay. Okay, you didn't receive the 4 and you send the SK3. Okay. What the blue node you do? The blue node you send there. The blue will send the 4, the 5, the 6, and the 7. Okay? You don't need to send 1, 2, 3 again because you already sent and the node, red node receive. Now you send the 4, 5, 6, and 7. Did you understand? Yes?
Yes.
Okay. But what happens if you didn't receive the 5? You received the 4, you received the 6, you received the 7, but you didn't receive the 5. What do you think? You need to send an escape, okay? Okay. The escape here, which number the escape will be? What do you think? Guys, come on.
Maybe 3.
4, no?
Exactly. Escape 4. Why escape 4? Give me a second.
Because it was the
SK4.
last one to return to red, no? And red sends 4 back, and since 5 didn't come back, red can't send a 5 back.
Exactly. And in this case, you need to retransmit which package? The 5, the 6, and the 7. Okay? Did you understand? Here, give me a second. Okay? In this situation, when you send escape 4, you need to send the 5, the 6, the 7, and the 8. Okay? 5, 6. Oh, sorry. No, yes. The 5, 6, 7, and 8. Did you understand? Yes, guys.
Yes.
Okay, it is the basic function of the TCP. In the TCP, you ensure that the message is received from the transmitter or for the receiver. Okay. Another protocol is the UDP. The UDP is completely different. The UDP, you don't have ACK. You send the data, don't matter if the receiver receives or not the message. If you have another package, you send. Okay. The UDP is used when it's more important to ensure the flow of the message than to ensure the corrections. When you need to ensure the flow of the message, then to ensure the correctness of the message. One example. I believe you already have the situation in the YouTube or in the Zoom or other. Sometimes you lost part of the information. For example, you watch a video, a move, and the move jump to a little ahead, or sometimes jump a little ahead. Okay, you lost part of the information. There are some toys in the internet, some page that you have part of information. Our brain can retrieve part of the information. For example, if you watch a movie and the move freezing and start again a few seconds late, 1 second ahead, it's not a big problem. We can understand the content, you can understand the message that the move tried to pass. It's the way that our brain works. It's the same to voice. The voice application has the same characteristics. If you, for example, talk with the phone and sometimes you lost part of the information, it's not a big issue if you lost part of the information. In this situation, if you send ACKs all the time, you increase the time that you need to the message arrive and the process. Again, remember the jitter is you influence the jitter. In the voice application, the video application, jitter is the bad guy. If you insert in the package an SK, you increase the chance that the jitter change all the time. Okay? In the UDP, you only send the message, it's connectionless. In the TCP, you send the message and receive the error. It's a good picture. Fix the TCP like this situation. You have the sender, all the time is the mommy, and the data is the baby, and the receiver is the dad. And the mom to take off your hands, ensure that the baby is very well protected in the dad, with the dad, okay? The UDP is like the crazy mommy. Send the data, okay? Send the data. It don't matter if the dad is playing FIFA soccer, for example, okay? It's what this picture tried to explain. Did you understand the difference between the TCP and UDP? Yes or no?
Yeah.
Okay. So we'll talk it because you need to study the IoT protocols. This picture is nice because it shows a lot of things that you already discussed in this course. If you see here in the physical and data link layer, you have the Bluetooth, Wi-Fi, the LTE, NB-IoT, RFID, the Bluetooth, and others. Okay, in the data link, the physical layer, it's what we studied in last class. In the network layer, you have the IPv6 or IPv4, okay? And the transport layer, you can have the TCP or you can have the UDP. Now you study the application data layer to the IoT, where you study the core, the MQTT, and today, okay? Today, we study 3 protocols: the core, the constraint application protocol, the MQTT, and the advanced message queue protocol, AMQP, okay? But our hands-on is about the MQTT. The core is the oldest protocol, okay? It's a protocol that you use in a very, very, very restricted areas. For example, smartwatch and others, okay? This protocol does not support a lot of protocols. And there is no very strong security scans for this protocol, okay? It's very simplistic one. The protocol use a language that is RESTful. The RESTful is a protocol that you can embed it more than commands, because I believe you already use the web browser, and in the web browser you use the HTTP protocol. The HTTP protocol, you can send data, you can send commands, but the commands and the data that you can send is very restricted, the time and the format. When you use the RESTful, you use HTTP, but you empower the HTTP, you increase the capacity of the HTTP, and you can use very complex data using JSON format. It's another format, okay? In a co-op, you have something like that. You have a clients, okay? Clients in the co-op, client 1, client 2, client 3, and you need to have the co-op server. Why you need to have the co-op server? Because these nodes don't have very strong capacity. It don't have a sometime memory, don't have a sometime process. It's only send data. But use a very local protocol. This protocol that you use in the co-op is not possible to be used in the internet. If you have some servers, or if you need to send this data to a server in the internet, you need to have a proxy. What the proxy does, it transforms the co-op message, embedded this co-op message inside a RESTful payload. Okay. Another way, I try to take a little easy. You get this format. The co-op proxy is the protocol that transforms the co-op message in the internet message. Okay. But the most used protocol in the IoT is the message queue telemetry transport protocol. It's a very light message protocol, okay, designed for high latency, low bandwidth, and unreliable network. Okay, this protocol consumes very little power on device. Okay, it's the idea, don't consume a lot of power, enabling that the device can run for long time without recharge. This protocol use a different architecture, use a publish subscribe architecture. The publish subscribe architecture is undesigned pattern, very useful. You use in the simulators and use in the web application and others. And the basic idea is you have a publish that publish one top, and you have a subscriber that subscribe to listen or to receive one top. It's like, for example, when you today is not so common to have. But think, for example, in the past, maybe 10 years ago, you buy to have a signature of a newspaper in the physical paper, no? And it means that you subscribe to receive, for example, the New York Times paper, okay? And the New York Times publish out every day a newspaper and send to your home, okay? Did you understand this model here, publish, subscribe? Do you have any questions? It's very important, okay? No questions? Okay, again, you have a publish that's published one top, and you have a subscribe that subscribe for one or more top, okay? It's a good example. Think that you have 1, 2, 3, 4, 5 publish that publish one specific message. For example, I'm on, I'm off. The temperature is 45 degrees, Celsius degrees. Today, you can send, for example, the forecast and others, okay? You have a publish that send the message, and you have an MQTT broker. What the merge MQTT broker does? The MQTT broker is the guy that receives all the publish and send reply or forward this publish message to the subscriber, okay? Think that you have your smartphone and you want to subscribe for the top forecast, okay? You go to the broker and say, oh, I want to subscribe the forecast, okay? And the broker save your information in your database, and all the published message that relate to the forecast, the broker send to you, okay? Not only to you, but to all the subscriber related to that part. Did you understand? Any questions?
No, teacher, everything's okay.
MQTT has multiple features. The first one is the quality of service. MQTT, you can define different type of service, for example, 0, 1, 2, or 3, okay? Depending on the quality of service, the broker hand your information in the different way. For example, if you have a bigger quality of service, QoS, the broker, when the broker receives this message, he forward very, very, very fast for you, okay? Don't put the message in the queue. You can have persistent session. You can have the last will. The last will is, for example, you have a subscriber or a publish, sorry, that need to disconnect very quickly. Cannot, because the MQTT use TCP, okay? Remember the TCP, you have 3 handshake to establish a session, okay? And to disconnect, to close the session or to disconnect, you have a complete process like a 3 handshake. But sometimes you need to disconnect very, very fast. You can send a last will message. When you receive a last will message, you know that the other party is already disconnected. You don't need to wait for to exchange message like you need to exchange the message when you start the session. Okay. Finally, you have again the MQTT. You have the opportunity to in the hands-on to work. Okay. The last protocol is the advanced message queue protocol. It's a very advanced protocol. Has a lot of features related to the security. Okay, but it has a very little problem because it's so advanced that it's very expensive to implement. Okay, you cannot implement, for example, in a very small device. This protocol has the most important feature is the support to multiple keys. Okay, you have Q1, Q2, and Q3. Each queue can have a different QoS. Another thing, each queue can have different security features. Things that this one is QoS 0, 1, and 2. Okay, what it means? When the exchange, the broker, receive a message and the message is related to QoS2, it's sent to this one. And for example, instead this queue is empty, you didn't start the one. Okay, when you don't have any data here, you start to process the data here. When you stop to here, you start to process the data here. Okay. And you can have the subscriber to different queues, okay? Basically the security features or basically on the QoS of the queue that you sign. When you compare MQP, HERO and MQTT, the MQP and MQTT use the TCP. The co-op use EGP. Okay. Again, the co-op is not an option. Okay, today. The party, The core base is request reply, the MQTT is publish subscriber, and the MQP is a point-to-point message exchange. Remember the queue, okay? You can have a queue to each device that you have. The MQTT is device to cloud. The MQP can use for multiple device to cloud, or cloud to cloud. Okay. Both has the same security, and the problem is the fault tolerance is not in the protocol. You implement the specific one that you want, and the fault tolerance in the MQTT is in. Remember that the broker is the single point for you. If you lost the broker, you lost the chain. Think about this picture here. What happened if you lost the broker here? What happened, guys? The subscriber
messages won't translate, no? And one can be sent, no?
Yeah, exactly. If you lost this guy, the subscriber stopped to receive any message. Okay. In the MQTT architecture, this guy is a big issue. Okay, but you have a way to solve this problem. You can create multiple brokers, and you can have the situation like the bridge mode broker that we studied today. Okay, you have some solution, but it's a problem. If you have only one and you lost this one, you lost everything. Any questions, guys? No questions? Okay. Okay, I will give a break now, okay? And when we turn, you explain the hands-on lab that you do during this session in the next one, okay? See you in 10 minutes, okay? We return on 49, okay? See you.